Voyager to turn its camera back towards Earth. And it's what's basically amounts to Earth's first ever selfie. And that picture was taken. And there was these pale blue dots. Decades the Voyager 1 has been making its journey through space, bringing us unprecedented information. Every single discovery sounded like it was impossible until scientists reviewed the data and confirmed that they were all real. And, well, another piece of puzzling information has just come through. Neil deGrasse Tyson has confirmed that the Voyager 1 just detected 500 objects passing by in space. And, well, that changes everything. Join us as we uncover what the Voyager's message really means and how it might just change the way we've thought about space exploration forever. What is Voyager 1? Voyager 1 launched back in 1977 has been cruising through space for almost half a century. Despite its age, this spacecraft is in remarkable condition and usually operates smoothly, but it's clear that something has definitely caught it off guard recently, leading to this strange behavior. Just to give you some perspective, Voyager 1 is currently over 14.5 billion miles away from Earth, and it's been traveling at a rate of about 3.6 times the distance between the Earth and the Sun per year. That's pretty impressive for a spacecraft that's been out there for so long. Those mysterious objects Voyager 1 claimed to have detected are fascinating. It's somehow been able to spot 500 unknown objects passing by in space. We're talking about things we haven't seen or identified before, totally new information, and something that no one was really expecting to find right now, which makes the finding even crazier. Sure, one possibility here is that the spacecraft's age is catching up with it. Think about it. Voyager 1 was launched way back in 1977, so its circuitry is around 45 years old. So it would make sense if the computers don't work the same way. But that hasn't really been the case. So far, one key aspect of the spacecraft's long life lies in its dual, redundant computer systems. Each Voyager spacecraft featured two sets of command computer subsystems, flight data subsystems, FDS and altitude and articulation control subsystems. This redundancy allowed for seamless transitions between systems and the ability to activate dormant computer components, and with it preserving their lifespan. Voyager to turn its camera back towards Earth, and it's what's basically amounts to Earth's first ever selfie. And that picture was taken. And there was these pale blue dots. Decades the Voyager 1 has been making its journey through space, bringing us unprecedented information. Every single discovery sounded like it was impossible until scientists reviewed the data and confirmed that they were all real. And, well, another piece of puzzling information has just come through. Neil deGrasse Tyson has confirmed that the Voyager 1 just detected 500 objects passing by in space. And, well, that changes everything. Join us as we uncover what the Voyager's message really means and how it might just change the way we've thought about space exploration forever. What is Voyager 1? Voyager 1 launched back in 1977 has been cruising through space for almost half a century. Despite its age, this spacecraft is in remarkable condition and usually operates smoothly, but it's clear that something has definitely caught it off guard recently, leading to this strange behavior. Just to give you some perspective, Voyager 1 is currently over 14.5 billion miles away from Earth, and it's been traveling at a rate of about 3.6 times the distance between the Earth and the Sun per year. That's pretty impressive for a spacecraft that's been out there for so long. Those mysterious objects Voyager 1 claimed to have detected are fascinating. It's somehow been able to spot 500 unknown objects passing by in space. We're talking about things we haven't seen or identified before, totally new information, and something that no one was really expecting to find right now, which makes the finding even crazier. Sure, one possibility here is that the spacecraft's age is catching up with it. Think about it. Voyager 1 was launched way back in 1977, so its circuitry is around 45 years old. So it would make sense if the computers don't work the same way. But that hasn't really been the case. So far, one key aspect of the spacecraft's long life lies in its dual, redundant computer systems. Each Voyager spacecraft featured two sets of command computer subsystems, flight data subsystems, FDS and altitude and articulation control subsystems. This redundancy allowed for seamless transitions between systems and the ability to activate dormant computer components, and with it preserving their lifespan. Power management to maximize efficiency. Voyager's instruments relied on hardwired logic. Because of the limitations in power budgets and time constraints during the development of the spacecraft's instruments, electrical engineers came up with simplified systems using hardwired logic, so the computer systems aboard Voyager 1 and its twin Voyager 2 had 6 onboard computers organized as a distributed system with 3 dual redundant pairs. A crucial aspect of maintaining the operational integrity of Voyager 1's computer systems involves ongoing power management. Power management plays a critical role in sustaining the operational capabilities. The Voyager 1's computer systems, given the limited power resources available on board the spaceship, engineers have devised several measures to conserve and optimize power usage. One notable aspect of power management is the selective powering down of non-essential systems. Engineers have taken a systematic approach to identifying and deactivating components or subsystems that are not vital for the primary mission objectives. For instance, heaters associated with certain science instruments have been switched off. These heaters were originally designed to maintain the instruments at specific temperatures to ensure optimal functioning. However, by deactivating them, power consumption is significantly reduced, thereby extending the overall lifespan of the spacecraft. The decision to power down non-essential systems is not taken lightly. It involves a careful evaluation of the trade-offs between power conservation and the scientific objectives of the mission engineers work in collaboration with scientists to determine the impact of deactivating specific systems on the quality and availability of scientific data. The goal is to strike a balance that maximizes power efficiency while maintaining the necessary functionality to continue gathering valuable information about the cosmos in addition to selective power reduction. Engineers also implement power management strategies that adapt to the changing conditions of the spacecraft's environment. For example, as Voyager 1 travels farther away from the Sun, the available solar energy decreases to compensate for this. The spacecraft adjusts its power usage accordingly. This adaptive approach ensures that the available power resources are efficiently allocated to support critical operations and data transmission. Anomaly not only that, but the ongoing technical advancements and improvement in power management techniques have allowed engineers to refine and optimize the power systems of the Voyager probes. Over the years, these enhancements include more efficient power distribution, improving battery charging methods, and advancements in power regulation and control. By implementing these meticulous power management strategies, engineers have successfully extended the operational lifespan of Voyager 1, enabling it to continue its remarkable scientific journey. Through the depths of space, the careful allocation and conservation of power resources have ensured that critical systems remain functional, allowing the spacecraft to transmit valuable data and insights back to Earth for as long as possible. considering the spacecraft was only supposed to last for 5 years and is still sending back information almost 50 years later, is astonishing. But knowing the meticulous work the scientists have to put into it to make sure that the spacecraft remains functioning helps put everything in perspective, too. It isn't just random luck that the Voyager is still going on. A lot of work and skill has gone into it, but that doesn't mean that nothing unexpected can happen in open space. Deep space is supposed to be unexpected. But even then, we do have some sort of idea of how things are going to be. Generally, you'd expect the spacecraft to just interact with meteoroids, asteroids, and space rocks, things of that kind, but the Voyager sending messages about detecting 500 objects was just too out there, which is why it became such a massive cause for concern. The researchers working on the project called this an anomaly because the signals came in unexpectedly, and there was no clear way of figuring out what was happening. Either what happened was that Voyager 1 started transmitting mysterious telemetry data back to Earth. Despite the unusual readings, the spacecraft remained responsive to commands from mission control, although there was a slight delay in communication overall. Investigation Voyager 1's antenna continued to point toward Earth, ensuring that the spacecraft could receive and execute instructions effectively, so there was no problem there. While scientists were confused by the mysterious data, Voyager 1 appeared to be functioning correctly and continued to gather and transmit data. One intriguing aspect of the anomaly was the fact that it did not trigger any onboard fault protection systems. These systems are designed to activate when anomalies are detected, putting the spacecraft into a safe mode that allows engineers to investigate and diagnose the issue. But in this case, Voyager 1 continued its operations without entering safe mode, further deepening the mystery after careful investigation. The anomaly was traced back to the altitude and articulation control subsystem. The AACS is responsible for precisely orienting the spacecraft and controlling its movements. It was discovered that the AACs had been sending telemetry data through an onboard computer that had ceased functioning years ago. This outdated computer, which should not have been involved in data processing, had somehow become entangled in the telemetry transmission process, leading to the corruption of the information being sent back to Earth. But at this point, too, it was confusing why this was happening. Was there really a horde of 500 objects that made the Voyager think it was in danger? They couldn't be certain until they fixed the anomaly to do so. The mission came up with a solution that involved instructing the AAC to redirect telemetry data to the appropriate functioning computer. This fix was considered low risk and was successfully executed. Although a major challenge faced by the mission team during this anomaly investigation was the significant time delay in communication, that's because of the vast distance that separates the spacecraft from our planet. Voyager 1, after its extraordinary journey, is now located approximately 14.6 billion miles away from Earth. So it takes a considerable amount of time for radio signals to travel through such a vast distance. When the mission team at NASA's Deep Space Network sends a command to Voyager 1, it travels as a radio signal at the speed of light. The Deep Space Network is an extensive network of enormous radio antennas, strategically positioned across the globe, enabling NASA to establish communication links with spacecraft. Exploring the far reaches of our solar system and beyond primary function is to facilitate two-way communication between Earth and deep space missions, as well as conduct radar and radio astronomy observations to enhance our understanding of the universe. Deep Space Network. The international network collaborates with various space agencies, including the Soviet, Chinese, Indian, and Japanese. Deep Space Networks, along with the European Space Agency's S-Track. By working together, these agencies create a unified effort to explore and investigate the mysteries of space, comprising 3 deep space communication facilities situated approximately 120 degrees apart. The DSN's locations include Goldstone in California's Mojave Desert, Madrid in Spain, and Canberra in Australia. This strategic placement ensures continuous coverage and observation of spacecraft as the Earth rotates, making the DSN the largest and most advanced scientific telecommunications system worldwide, operating on the principles of radio wave transmission. The DSN communicates with spacecraft by utilizing the colossal antennas. At its stations, these antennas send and receive radio waves, establishing a vital link between Earth and the distant probes when transmitting data from the spacecraft to Earth deep space. Network channel 18 is typically used utilizing frequencies of either 2.3 GHz or 8.4 GHz. On the flip side, when sending signals from Earth to Voyager 1, a frequency of 2.1 GHz is used, and all of it happens at the speed of light. However, even at this tremendous speed, the signal requires approximately 22 hours to reach the spacecraft. This means that after a command is transmitted, the team must wait patiently for 22 hours before receiving any confirmation or response from Voyager 1. This time delay posed unique challenges for the mission team. It requires careful planning and precise execution of commands, as any errors or issues can result in additional delays and complications when investigating anomalies like the one experienced by Voyager 1 this time. Delay prolongs the diagnostic. And troubleshooting processes. Commands must be carefully crafted, taking into account the anticipated response time. So every time a message is received, it's actually adding to the information, not just being a waste of time. The time delay also limits the real-time control and interaction with Voyager 1. Unlike missions within our solar system, where the time delay is relatively small, interstellar distances introduce a significant lag in communication. This makes it impractical to conduct instantaneous conversations or make quick adjustments based on real-time observations with a lot of back and forth. The anomaly was fixed at the source and shut down the faulty computer. Possible causes. But the craziest thing is that the reason why the AACS started routing telemetry data to the incorrect computer remains a mystery. It's suspected that the AACS received a faulty command from another onboard computer, but the exact cause has still not been found. There are a few possible explanations, though. In the vast expanse of space, the environment can be an unforgiving and unpredictable adversary for spacecraft like Voyager 1. Cosmic radiation, extreme temperatures, and micrometeoroid impacts are just a few of the environmental factors that can potentially impact the delicate electronic systems on board cosmic radiation, consisting of high-energy particles from distant stars and other celestial sources fill up the space between galaxies. These particles, including protons and cosmic rays, can penetrate spacecraft structures and interfere with the functioning of electronic components. The intense radiation can cause electrical disruptions, alter data signals, and even lead to memory errors or data corruption, so it could possibly lead to the computers on board the Voyager getting confused and sending out incorrect data. Extreme temperatures also pose a significant challenge for spacecraft operating in the harsh vacuum of space. Voyager 1, being in the outer region of the solar system, is subjected to extreme cold, with temperatures reaching as low as -202 degrees Fahrenheit. Such extreme temperature variations can impact the performance of electronic components, leading to unexpected behaviors or errors in data transmission. But those aren't the only things There's also the presence of micrometeoroids, tiny dust particles or fragments of comets and asteroids, which can also pose a threat to spacecraft despite their small size. These micrometeoroids travel at high speeds and can cause damage upon impact. Even a minuscule collision with a sensitive electronic component can disrupt its functionality or create interference in data transmission. While these are possible reasons, there's also one more that's been quite popular among the science community. It's the possibility that the anomaly wasn't just a malfunctioning computer. Someone turned the old computer on manually and sent that message. Yes, we're talking about aliens. It's possible that there is a highly advanced alien civilization with capabilities far surpassing our own. These extraterrestrial beings could possess sophisticated technology and an in-depth understanding of space exploration. Considering that the Voyager is now extremely far away from Earth, it's possible that it's made its way into alien territory, aliens that we're too far away from to discover. Since the Voyager is designed to hunt for more data, it's possible that it could have encountered this civilization and tried to find out more, only to end up getting taken over instead. And that may have been the reason why the computer malfunctioned in the first place. Maybe it wasn't really a malfunction, but a discovery instead. But if that were the case, how would we know if something like that had happened? Well, the answer to that lies in the communication system. You see, Voyager 1 relies on NASA's Deep Space Network for communication with Earth. This network includes 3 stations on Earth equipped with a 3.7 meter diameter, high-gain Cassegrain antenna, which allows Voyager 1 to send and receive radio waves, the one that's always pointed towards the Earth. The spacecraft typically uses deep space, network channel 18 to transmit data to Earth. It operates on frequencies of either 2.3 gigahertz or 8.4 gigahertz for data transmission, while signals from Earth to Voyager are sent at 2.1 gigahertz. Scientific instruments. In situations where direct communication with Earth is not possible, Voyager 1 has a digital tape recorder on board. The recorder can store approximately 67 megabytes of data, which can be transmitted to Earth at a later time when communication is restored, so the scientists will be able to extensively study the data it is recorded in the time that it was malfunctioning and figure out if aliens might just be the answer. But that's not all. If Voyager 1 did in fact make contact with aliens, it's got all of the instruments needed to gather very detailed information. The spacecraft carries a remarkable array of scientific instruments, each with its unique purpose. These instruments are part of the attitude and articulation control subsystem, which ensures the spacecraft remains stable and keeps its radio antenna pointed toward Earth. Among Voyager 1's scientific instruments is the cosmic ray subsystem, which measures the intensity and properties of cosmic rays, shedding light on the cosmic environment beyond our sun. Working alongside is the magnetometer, carefully analyzing the strength and direction of magnetic fields encountered in space. By doing so, it helps us understand the interactions between the solar wind and the vast expanse of interstellar space. The photopolarimeter subsystem here plays a vital role by capturing and analyzing light, particularly polarized light, through its observations. Scientists gain insights into the composition and characteristics of interstellar dust particles and other celestial objects. Complementing this is the plasma science instrument, which dives into the properties of charged particles known as plasma, providing valuable data about their densities, temperatures, and velocities. This helps us understand the dynamic nature of plasma within the interstellar medium. The low energy charged particle instrument is the instrument that's responsible for studying the composition and energy distribution of low energy charged particles, such as electrons and ions. By examining these particles, we gain a deeper understanding of their sources and the mechanisms behind their acceleration in the vast reaches of space. There's also the plasma wave subsystem. This instrument detects and analyzes naturally occurring radio and plasma waves, enabling scientists to study the properties of the interstellar medium and the intricate interactions between the solar wind and its surroundings, venturing into the realm of light. Voyager 1 carries the ultraviolet spectrometer 2. This instrument meticulously measures the intensity of ultraviolet light that comes from all different types of celestial objects, so it's able to easily study the composition and physical properties of gases within the interstellar medium. The infrared radiometer also joins in here by analyzing the thermal emissions of objects encountered on the cosmic journey. By doing so, it reveals valuable insights into their temperatures and thermal properties. Working hand in hand with the iris is the interferometer, which examines the interference patterns of infrared light. This allows scientists to study the composition and physical properties of gases and particles encountered by Voyager 1, unraveling the intricate details of the interstellar medium, completing the very complicated instrument. SWEET is the spectrometer which operates alongside the iris. This remarkable instrument is responsible for studying the composition of gases and particles by meticulously measuring the absorption and emission of light at specific wavelengths. With that, it provides vital clues about the chemical makeup of the interstellar medium, enhancing our understanding of the cosmos entirely. While these scientific instruments are tirelessly collecting data, the high-gain antenna ensures their findings are transmitted back to Earth, with a strong and reliable signal acting as the communication lifeline. It ensures effective and ongoing communication between Voyager 1 and Mission Control, enabling us to receive the treasure trove of knowledge gathered by these instruments. And it definitely has been a treasure trove for sure. Voyager 1 and Voyager 2 provided the first direct evidence of the heliopause in 1993. The heliopause is the boundary that marks the transition between the solar wind from our sun and the interstellar medium. This discovery confirmed the existence of a distinct boundary separating our solar system from the vast expanse of interstellar space. This discovery was crucial in our understanding of the outer boundaries of our solar system and the interactions between our sun and the interstellar environment. During its encounters with Jupiter and Saturn Voyager, 1 made remarkable discoveries regarding the moons and rings of these giant planets. At Jupiter, Voyager 1 identified a previously unknown thin ring encircling the planet. It also discovered 2 new moons, Thebe and Métis, according to Jupiter's known moon population. Similarly, at Saturn Voyager, 1 found 5 new moons and a new ring called the G ring. These findings expanded our knowledge of the complex systems of balloons and rings around these gas giants, providing insights into their formation and dynamics. One of Voyager 1's most fascinating discoveries was the presence of active volcanoes on Jupiter's moon. Io Voyager 1 observed plumes of erupting lava reaching heights of hundreds of miles. These volcanic eruptions are fueled by the tidal interactions between Io Jupiter and its other moons. The discovery of such intense geological activity on a moon in our solar system broadened our understanding of the variety of dynamic processes occurring beyond Earth, showcasing the unique characteristics of planetary bodies. Voyager 2. A companion spacecraft, 2, Voyager 1 also made notable contributions during its encounters with Jupiter, Saturn, Uranus, and Neptune. But if you take away from the planets and the moons, there's a lot of gap in the middle. It's space, after all. However, the Voyager even found a way to discover something. Here, we're talking about the fact that it was the first direct measurement of the solar wind termination shock. The termination shock is the region where the solar wind, a stream of charged particles emitted by the sun, slows down and becomes denser as it interacts with the interstellar medium. Voyager 2's measurements brought us valuable data on the structure and characteristics of this boundary region, and now we know more about the interactions between the solar wind and the surrounding space. The Voyager missions have had a lasting impact on our current exploration of the solar system. With all the flybys of the outer planets and their moons, the Voyager spacecraft captured detailed images, collected data, and provide invaluable insights into the diverse features and dynamics of these distant worlds. So it wouldn't really be a stretch for it to also be able to gather data about an alien planet and aliens on it. It's possible that the data the Voyager was sending wasn't just a malfunctioning mess, but actual details about 500 objects that no one thought were there before. If it can be the one to bring us to many significant discoveries, it might just be the one to confirm that aliens do exist and they're not afraid to make contact with our technology. But is that what really happened? And if it is, would the reps at NASA actually announce that we might have to wait for the scientists to officially make it through all the data they have about the incident to find out? And when we do, you'll be the first to know. Right here, what do you think, though? Was it just another glitch in the system? Or are aliens finally making contact? Let us know in the comments below. If you liked this video, please give it a thumbs up and subscribe to our channel for more videos just like this. And as always, we'll see you in the next one.